70 milliseconds in duration. Although this distinction is made, and we often categorize discharges in this way, from a practical perspective, there does not seem to be any difference in the biological significance of a spike versus a sharp wave. The second characteristic is that this discharge has multiple phases. If we look very carefully at this discharge, focusing on one of the channels, we can see that there's actually an initial positive phase, then the largest negative phase, then a third positive phase, so that we would call this a three-phase or triphasic discharge. However, it is important to distinguish this from triphasic waves, which have a different clinical significance. This discharge should interrupt the background. In other words, it should not simply look like a continuation of normal background activity. We can see that this discharge clearly stands out from the background, and there is a disruption in the background before and after the sharpest component of this discharge. In general, there should be an after-coming slow wave after epileptiform discharges. Again, we can see this here, here, and here. Finally, there should be a field that makes sense. We have reviewed polarity rules in a different recording, but you can see that there is a downward deflection at F_P1, F9, a relatively flat recording at F9, T9, and an upward deflection at T9, P9. This would suggest that the maximal negativity is at F9, T9. Similarly, in the regular temporal chain, we see a downward deflection at FP1, F7, and an upward deflection at F7, T7, suggesting that this is electronegative at F7. Therefore, we would say that this is a sharp wave, or sharp and slow wave complex, with maximal negativity at F9, F7, and T9.